take a look at this compound. I have, can you tell how many carbons are on there? 4 carbons, right? See that double bond in between those two? What's the name of that compound? 2-butene. 2-butene. All right, I'm going to leave that. Grab this one. And I want to show you this compound. What is the name of this compound? 4 carbons, double bond between numbers 2 and 3. What's this one called?
2-butene.
Also called 2-butene. I'm going to hold these up next to each other, like this. And I want you to ponder if those are the same. I'm missing one more hydrogen. Are these two the same compound? We just called them both 2-butene. And I have a slide with this on it. No, I was not going to do that one. Okay, so for this structure, we see that we've got the double bond between carbons number 2 and 3. There's our parent. And the parent starts kind of above where the double bond is. This angle right here is all 120 degrees. Yes? See that 120 degree angle? The parent goes through the double bond, and then over here, also 120 degrees, the parent ends on the same side of the double bond as where it started. Started above the double bond and ended above the double bond. Over here, this compound, and that's going to fall out. Let's see if, okay. This one starts above the double bond and then goes through the double and ends below the double bond. Even though they're both 2-butene, these are not the same molecule. Now, you saw when I was messing with the hexane before I made it to cyclohexane, I said, kind of in passing, that the single bonds, they can rotate. A double bond cannot rotate. You got 4 electrons being shared. If it's just a single bond, remember that's a sigma bond. The electrons are right in between the two atoms. If you have a pi bond as well, that kind of fixes the bond. It does not allow for rotation. Because of that, these two things, even though they're both 2-butene, they have different properties. They're different compounds. So how do we name this? If they're both 2-butene, they have to have a different naming system, and that's where we're going for the last part of the hour. Both of these structures are considered 2-butene. Here's what we do to name them. If the parent chain continues on the same side as where it started, so if it ends on the same side as where it started, we're going to use, we'll still call it 2-butene, but we stuck a prefix on the front of it, cis. C-I-S. Cis. So that's this one, it's cis-2-butene. Starts above the double bond, ends above the double bond. This one is not cis-2-butene. It starts above, it ends below. If the parent continues on opposite sides of the double bond, we're going to use the prefix trans. This one would be called trans-2-butene. I can't think of any English language word that uses cis as a prefix. Trans, though, there's a lot of trans. Like what? Trans what? Transmitter, right. And transparent. And transatlantic. And transgender, but I don't want to say that one. What does trans mean? If something is transparent, what does that mean?
See through it.
You can see through it, right. If you take a transatlantic flight, what does that mean?
You're going across.
You're going across, yeah. Trans does mean across. Yeah, so transparent means you can see kind of across the membrane or substance. Yep. All right, so now just last thing was cis and trans. And again, as I told you at the beginning of the hour, we were waiting for the computer to start. Do some homework problems. When you get to the geometric isomers, though, cis, trans, stop. That would be good enough for the weekend. All right? No, there will be a lot of nomenclature. Name this compound, draw the structure of this. Yeah, the isomers. Yep. Yep.
So basically, what you've done.
Yeah. Yeah. All right, you guys have a nice weekend, too. Thanks.